Tetris, one of the most played games in history. A game as old as it is very interesting. Have you ever wondered through what is behind such a game? Well, if the answer is no, then follow me, because today we will go and see how Tetris is made behind the scenes. Okay, then I want to start by saying that this project was done with the only purpose of learning new things. Having said that, let's start with explanation of what I made. Yes, we're not going to go look at the original code of the game because it's written in assembly and I know very little of assembly. So I made my own copy of the game and I want to take you along with me and on the path that I took to be able to create it. And maybe, who knows, help you as well in being able to create your own copy. So now we start to talk about the idea of my project itself. What was my idea? Originally my idea it was to make a Tetris clone, but that not only works on single player but also in multiplayer. And yeah, this was a very big idea and very big project, and obviously I've not done the multiplayer feature yet. Maybe I can do it in the future, but for now I have not done it. So in which language I'm gonna make this project? I'm gonna do it on C++. Obviously it is my favorite programming language and is the programming language that I know the most, and I think that is the best for doing this project. I also gonna use CMake for set up all the project, and obviously I need a graphic library for work on Tetris clone, and I'm gonna use for in this case SFML version 2.6.1. If you're interested on know more about the library that I used, I'm gonna put in the description all the links. Also, I want to say that I made a repository on my GitHub, so if you wanna take a look at my code and the project itself, you can go on GitHub and take a look at everything that I made. Also, I want to say that in the project that I made, there is also the library inat that is used for make the multiplayer part that I have not already implemented. So, it's time now to make our first window on SFML. So, how can we make a window on SFML? Well, simply like that. Only 3 lines of code? No, not really. So this is our main that I've done, and there are only 3 lines simply because the first one is a pointer that is pointing at an object, call it game, which is our game itself, where I put all the code of the game inside a class. Then we have a game arrow init that simply start our game, make our window, and do everything. So I usually use classes for work on C++. Yeah, my main is very simple and I want to keep it the more cleanest as possible for do not have a lot of code here inside. So we can pass to the second part of the code, which is the window. So we need to make a window. I don't want to go very deep on the details on how can you make a window on SFML, but simply the first few lines are essentially for make the window and then initialize a GUI That spoiler, I never use it, so it's useless. After that we have our main loop where our window it is kept alive by that, simply because if you don't continue to keep it alive with a while that is almost infinite, your window gonna be closed technically instantly after you have opened it. So we need a while for keep it alive. Well, this essentially is all the code that we need for make a window. And so we can start by try to open the window and see if it works. And it works! Well, now we have a window, so we can make the game. Yes, we can make it. But first we need to think about Tetris and how the game works. So let's go to take a look at the game. Okay, so let's take a look at this example of Tetris. As we can see, the game itself is very basic. There are different tiles which are made of blocks, and every block can be represented like a pixel. Is not real a pixel, but we can figure out in this way. So how can we make this? First of all, we need to make a grid. As you can see, this example of the game has a grid where every piece slide down every few seconds. So how can we make this grid? In programming, there are a few ways for doing this. There is the static and dynamic way. And how this grid can be made more specifically. In programming, this is called multi-dimensional arrays. If you don't know what an array is, well, simply we can say that is like a drawer. Yeah, like a drawer where you can put a lot of items one next to each other. Yeah, I don't know how to explain well an array, but you can see that an array is a straight line made of different cells, one attached to each other. Well, the multi-dimensional array essentially is the same thing, but is not only on the wide, but is also on the height. So we have multiple cells that make a grid. Perfect, so we have a grid and the work is done. No, it's not done. Because we need to make a way for simply display those grids, those cells that we have on the grid. And this is completely another story. Because yes, we can use a static array, but also a dynamic array. I'm gonna call it this grid a matrix because it's simple and it's so long to say every time multi-dimensional array. So it's also possible to call it matrix. We're gonna call it matrix. So make a static matrix is a good idea, but we can also do it dynamically. So let's take a look at the code. Okay, so we need to see if the code that I write works. So 3, 2, 1, we can run it. And seems working. So what I write? Let's take a look. First of all, we have here private method of the class called makeGrid. That simply is a brute force algorithm, as you can see, because there are two for loops. So what I've done, it was very simple. I made the grid with a dynamic vector, and then I put in the first line the size of the cell and I use the SFML vector, that is a vector 2f, for make the cell size. Then I made it transparent. I have put outline color on white and outline thickness on 2. So now we need only to find a way for find the center of every single cell. How can we do it? Well, simply we can use math for find every single coordinates of every single cell, and we need only to find x and y points. So for find the x, we can simply use the I index multiplied by the cell size plus the window size on x-axis divided by 3. Yeah, and it's simple. Then for find the y, we can use j multiplied by the cell size plus 10. Don't ask me why 10, I don't remember right now. In this way we can find x and y points, and those are our coordinates for put our cell, and at the end of these loops we have all the cells in the correct position. We need only to display them with another for loop, or more specifically with another brute force algorithm for draw everything on the screen. And this way we have a working grid on the screen. We need only to make the game itself. So the next step basically is simple. We need only to draw the figure, the piece that we want to display on the screen, and make it falling. And this is not very complicated to do. Well, not really. It's not very simple, at least at the start, but I think that I found the best way and simplest way to make the thing easier. And when you see it, you probably say to me, yeah, you're right. This was the most simple idea that you can have for make all the pieces spawn easier and folding easier. So let's take a look. Okay, well, we need to find a way for display all the pieces in the correct position, because every time is indifferent if the piece is a O or a Z or a L or a J, and those are all the names of the piece on Tetris. Is indifferent which piece we are gonna draw. We need everything every time to display and draw it on the same spot. So how can we do it? Well, if we take a look, every time we need to draw them in the same coordinates, and there are a total of 8 cells that we need to use, simply because there is not a piece that is bigger than 2 cells on wide, and there is not also a piece that is bigger than 4 cells on height. So we can simply choose the center of our grid, choose 8 of those cells, and every time display and draw all the cells in those cells. Simple. Well, we need a way to save the information of the piece. And in which way we can do it? Well, first of all, we need to save all the information of the pieces that we need to draw. And for doing this, I use again another matrix, but this time I've done it dynamically. You are asking me why I've done dynamically? Well, because I used a structure for save all the information. Simply, we need to save the X and Y position of all 8 cells on the screen. How can we save those coordinates? Well, with a structure that I call it a block. which save x and y points. Then I've done this dynamic vector, and really is a vector of blocks. Yeah, really strange, but it's normal on C++ programming. And then I put inside all the coordinates and for every single piece on Tetris, so Z, S, J, L, O, T, and I. And then we are ready for draw them, because yeah, we have done almost all the work. Now, how can we draw it? Well, we need to find a way to draw randomly all the pieces. And this is not a problem, because on C++ we have all the functions for make a random number. So I generate a random value, and then I use this value for search inside the vector, and then draw the piece that I found with the random number generated. But is not all, because we need to make it falling. How can we do it? Well, this was not simple, at least at the start, because I had to figure out a way for save every time its coordinates. How can we do it? Well, simply we have already made a structure which allows you to save x and y. We can use it. Yeah, we can use it. It's very simple. We don't need to make other temp variables for save only x and y. We can use them. Well, now what we need to do? Simply after have choosing the piece that we need to draw randomly, we need to use another variable that I call it piece, which is the piece that we need to looking every single time that he falls. Simply because maybe it can collide with other piece already placed, or it can go outside the border of the grid and make out of memory exception, I don't remember, so the game crash. We need to check a lot of things, and for that I make an array of pieces, so it's a block piece array with a width of 4, because we need only to check 4 blocks every time. Because yes, if you take a look on every single piece on Tetris, every piece have only 4 blocks, so we need to check only 16 points on the screen. So it's not a very big deal, you know. Well, now we need only to make it possible to fall, and I have simply done a function called move down piece. Okay, so simply this code is very simple, because there is a function at the start which allows us to clear all the blocks that make our piece that we are currently using. So we're gonna remove the piece from the screen. Then there is a bool variable that allows you to check one thing later, and then there is this for each loop. So now how this works? Simply after I've taken an item, more specifically one object from the array piece, we go inside the if statement, and we are gonna check if the y plus 1 is smaller than rows. And what does it mean? It means simply that if we are gonna check if the piece is not come to the bottom. If you come to the bottom, there is an else that put fail on true. And so that means that the piece needs to stop falling and place there and moving to another piece. But if we're not at the end of our grid, we are not come to the bottom, there is another if that go to check on the grid at c.x and c.y plus 1 coordinates, get the color of this cell and check if it's transparent. If it's transparent, that means that there is not other pieces already placed, so we can move one cell lower. Otherwise, we have a fail equal true and then do a break, simply because we don't need to check other piece. We need only a piece that is being stopped by another cell. And then we have the last part of the code, where is the an if, and inside the if there is a not fail. So if fail is false, we are gonna put a not in front of the fail, so we have true, and we can go inside, move one piece lower, the piece, and draw again the piece. So we're gonna take the last position, increase of 1 of high, and then draw again the piece in the new position. If a fail is true, we have a not in front, so it's false. We're going to the else statement, and we're gonna draw again the piece, but this time with the old coordinates. Then there is a function called the checkpoints. We are not gonna look at it for now because I made it later. And then there is a draw piece that simply is the function that allows us to draw a new piece and move it. So we're gonna make another piece with a different shape, like another O or a E or a J, etc. So we're gonna make a new one. Maybe you can ask me, right, but if you go to draw another piece, you need to make another array of blocks. No, simply you can use the last one, but only with changing the x and y the coordinates with the new one. In this way I can reuse the same array, and the old piece that I was using is not possible to use anymore, and I can move the new one. Simple. Okay, well, we need only to try if this code works. So 3, 2, 1, let's see. Well, it works. So now we can draw the pieces and we can make it folding. We cannot move it for now, but it's something. Now we can see the piece, and every time that we start the program we have a different piece. Very interesting. Now we need to implement the motion of those pieces. So it's time to add other code to our project. But we need to check how can we do this. So follow me again, and let's see to find a way for make the motion of all the piece. So how can we move our piece around the grid? Technically there are 4 different directions that we can move the piece. So there is up, down, right and left. But what is the problem? Right now there is not a problem, but we need to think that there are 2 directions that we don't need to use. For example, the up direction. We don't need to move our piece up. And the down direction is not necessary, because every few seconds our piece falls down of one cell automatically, so we don't need to take a look at it. So we have only two directions that we need to program, the right and the left. And you probably think that is not very difficult to make. Hello. And you are right, it's not very difficult to make, but there are a few things that we need to keep in mind. For example, if the player moved the piece on the right, but it's already in the last spot possible of the grid or the matrix, so how wanna call it. If the player go right again, it can maybe get out of memory because there is not another cell, and the same things on the left. So we need to check every time, but also we need to check if moving the piece on the right or the left, there is another piece already placed, so there is a collision. And no, we don't need to make a collision. We can check only if the piece, if on the grid there is already a piece or not. We don't need to make collisions, tracking, etc. We need only to check the color of the grid. So let's take the code, for example, for move right the piece, and the left is almost the same, but there are a few differences. So first of all, we need to clear again the piece, so we need to remove the piece from our matrix. Then there is again another bool variable for check, and we'll see later what it does. Then there is again another for each, and it's almost the okay, I was saying it's almost the same code of the moving down piece, so there are little difference, but let's see. So there is a for each. After the for each, there is again another if statement, where we see dot x plus 1 is bigger than calls less 1. So what does it mean? It means simply that if we move our piece on the x-axis one step forward, so if it is on this spot, we move on the right. If the value is bigger than the number of columns that we have less 1, obviously, because in programming we start to count from 0 to n less 1. So if we have for example an array of 10 elements, obviously we don't go to say we have 10 elements, we have 9 elements, because we start counting from 0 to n less 1. So in this case we have the columns that, if I remember correctly, are 10 columns on Tetris, so less 1, 9. So we need to have c.x plus 1 that is bigger than columns less 1. So if it's true, so if it's bigger, that means that we are came out of the array, so there is probably an out of memory, and we don't want it. So we go inside and there is a fail equal true, there is a break, because I already explained we don't need to check other piece if one of them go out of memory or if collide, and so we do other thing, but let's see later. But if this is not true, there is another else if, and inside this else if there is a grid.c plus c.x plus 1 and c.y get fill color different from transparent. So what does it mean? It means simply that if we are not came at the end of our matrix, well, we can go one step forward on the x-axis on the right, but before doing this we need to check if there is already another piece placed on the map, on the grid, sorry. So we need to take the color and check if the color is different from transparent. If it's different from transparent, well, we have found another piece already placed, so that can be called collision. So we are colliding with another piece and we cannot move our piece on this spot. So we need to put fail on true and do another break. So after this for each loop, there is an if statement with a fail, not fail. So again, if a fail is false, there is a not, so we can go inside. And there is a for each loop again that increase our x, and so we move the piece. Well, in this way we have moved it, but if fail is equal to true, we cannot move it, and we can leave the piece in the same position and draw it again. Well, this was the code, very simple for moving on the right. Now we are gonna check how can we do it for the left. For the left is almost the same thing. We need always to clear our last position, make another bool variable for each loop, and the if statement. The if statement this time is a little bit different. It's c.x minus 1 equal to minus 1. What does it mean? It means simply that we're gonna remove 1 from c.x, so we do c.x minus less 1. And then we're gonna check if the value of c.x is equal to minus 1, we have a fail equal true. Why this? Because we cannot have a negative index on the array. The negative elements doesn't exist on programming, specifically on the arrays, or this for C++. In Python is another story. But in this case we are on C++, so if it's equal to minus 1, we have an error. We have an error. Why? Why? Simply because the programming language try to check if a minus 1 index exists, and this obviously it doesn't exist because we start counting from 0 and we go so on. So we need to put fail on true and do a break. But obviously if it's not equal to minus 1, there is another if statement with a c.x minus 1, c.y get fill color, and we check again if it's transparent or not. If it's not transparent, we cannot go on the left. If it's transparent, we can go simply. And then there is the same for each that I already explained. Simply this time there is not a c.x++, but there is a c.x minus minus that go to decrease the value of 1 on the x, and then we can draw again our piece. So really is not complicated to move our piece around the grid. We need only to check if there is already a block placed, or if we come to the end of our grid and we cannot go forward. So now we have done the motion. It's time to check if it works. Okay, well, it's time to check if it works. Let's see. 3, 2, 1. Okay, I think it works very well. We can move it around the grid. So right now we have a fully working Tetris game that we can move the piece around, and we need only to do a few things for can say that this is a full Tetris clone. We need only to make the score, so every time that we make a full line we need to remove it, make a score, and yeah, we have done it. And also a end game, so if you go to fill the entire grid and we need to make a losing screen, something like that. We'll see. Okay, so it's time to see how to remove a line and make score. So again, let's try to think it, because this time there are a few tricky parts that we need to check. Okay, so it's time to check how I managed to check the points and for remove the lines that the player have made on the grid. So let's start with this function that I call it checkpoints. So this is not very simple, but we'll see. So I put a counter equal to 0, then I made a 4, a normal 4, so where I created the index I and I minus 20. Why 20? Because there are 20 rows in total in our grid. There is at the end of the 4 this plus I, but it doesn't matter, it's a normal 4. Then there is another 4 with index j equals 0 and j minus 10. Why 10? Because 10 are the number of columns. Then there is an if statement with a grid index y and I. Dot get fill color, so we're gonna take the color from our cell, and if different from transparent, so if there is a color inside, we can increase the counter. Why we are doing this? Simply because we need to check if in a row there are 10 blocks of some colors. Is indifferent the color. It needs only to be colored. So if there are 10 blocks colored, that means that we have a full line, and so we need to update the score, and there is a code that simply increase the value. And for make the thing easier for me, I've only put that if I do a full line, I go to increase the score of 100. So there is update score, and then another 4 with index j equals 0 and j minus 10, so another time this is for the columns, and go to set all the blocks that we have already checked on transparent. So we are going to remove every blocks of this line. Then there is another 4 with k equal to I and k bigger than 0 and minus k. So I'm going to explain directly what this double for loop do. Simply go to check every time the line above, and let's go to see if there is a block, if the cell above is colored. It go to take this cell and move it down. Try to think like that, but you really go to put it on transparent, and no, set the fill color on the actual cell that is looking, and go to put transparent the cell above. So this is for make the idea to the blocks that are falling, but they are not really falling. I'm changing the colors of the cell. It was the simplest idea that I had. So I go to check above. If above the cell is colored, I go to put on transparent, then go to the cell underneath and put colored, and repeat this for every lines above the line that we have removed. So I don't need to check from the start, from the bottom of our grid, because if I remove a line from the center, it's useless try to check from every line from the bottom. I need simply to check from the line that I remove above. And there is another thing that I not implemented, but it is possible to do. I can see at some point that maybe there are not other blocks. Maybe we can have some lines that are empty. And if the lines are one or two lines are empty, that it means that we are come at the end of all the blocks. So there are not other blocks to move. One step, one cell under. So we can stop the for loop. But I have not implemented this. It was simple, but I think about it later when I finish the project. Then there is a counter equals 0 because we need to check again if there are multiple lines. Because we don't know, maybe the player is very good at Tetris and he can do more than one line at the same time, so we need to remove more than one line, and so we need to put a counter on 0 and repeat. This check is important to do every time that the player the piece that the player is controlling stops. So if the piece dropped down and collide or it came to the bottom, we need to check again if the player have filled an entire line or not. So this part of the code is important to be repeated every time, and in fact I already showed you at the start of the video that I called the function when I moved down the piece. Okay, well, it was not very complicated, at least once you have found the solution, it was not very difficult to implement it. I remember that at the start I struggled a little bit on finding this solution, but then I had this idea and it was very simple to make the code. So it's time again to check if it works. Okay, wait a second, I'm there. Okay, it's time to check if it works, so 3, 2, 1, go! Okay, I'm gonna speed up the thing because we need to play a little bit for check it, but I can see that it works. So we are removing all the lines that we are making. So as you can see, it works. It was not very difficult. We have a fully functional score. Yeah. Now what we need to do, we need to do only one thing that I have not done because it was terrible. Yeah, trust me, it was not funny, this part. And this part is rotate the piece. Well, trust me, it was not a funny thing to do, and I think that this is the worst part of my code. I think that is terrible how I made it. Maybe you can find a better solution, but this is how I made it. So it's time to check the theory behind what I've done. So let's go again to check. Okay, well, this time I want to do something different because it's very complicated, the code that I've done, and I think that is not the best idea possible for make the rotation of the pieces. So I want to show you obviously the code, but I don't wanna go to explain you how what there is written right there, what I've done. You can figure it out alone by reading the code, but I'm going to explain you a little bit my idea behind this code. So simply, at the start, when I go to take the piece, when I go to generate the piece randomly, I go also to put on a variable, on a char variable, a lector that is the name of our piece. And well, now this lector is important for make the rotation. So in this way we don't need to check what piece we have. So I'm gonna take, for example, the piece L, and I put here an image where I show you what I thought. Simply media, it was simple. I have only 4 pieces that I need to move. Well, from the starting position, we need to rotate it of 90 degree, and then another 90 degree, and then a 90, and then we came to 0 at the original position. So for example, we need to move the piece on position the piece 0, 1 on the right and 2 down. Then we need to move the piece 1 cell down, the piece the piece 2 1 cell on the left, and the piece 3 1 cell up. And in this way we have the rotation, because we have moved all the pieces in another cell, and by doing this we have got the rotation of 90 degree. So we can repeat this process and we get again another rotation, and then again, and we have another rotation. You can follow the arrows that I draw, and you can see that every time we move all the cells in the correct position. But this is the simplest part. The difficult part, it was at the start that I need to move the cell 0 in one spot, but at the end of the rotation I need to have the cell 0 in the exact same location that I done at the start. So you need to go back in the same spot from where it started. Obviously it will not be in the same coordinate, but in the same position, because if I do another rotation again I need to have the rotation correct. And this sounds very strange to hear, I know, but if you try to do the code alone, maybe you can figure out this problem. Yeah, this was the example for the L. Other pieces are more simple, like the Z and S, because they only have one rotation. Or, for example, the O, that is not necessary to rotate. I think that the only difficult it was this one. So the L, no, and also the J, it was difficult. The O is not necessary to do rotation, the I is only 2 rotation, S and Z are the same, there are 2 rotations. So only L and J I think that are the most difficult to rotate, and also T is very simple to rotate. Yeah, so I found this solution for rotate all the pieces, moving the cells, and I think that on L and J there are a few problems after some rotations, but I've not found the why. I have not found a solution for remove those problems. I don't know where the problem is in the code, but it's very rare. It doesn't happen so commonly. Also, another thing important is to check before a rotation if we can rotate, because it is not 100% correct the idea that we can rotate, because maybe we do a rotation, but with a rotation we go on top another piece, and so we go to remove the other piece already placed. We need to check if the rotation is possible. Maybe there is not enough space for make the rotation, and so we need to check every time all the pieces where they are going and check if the piece the position that they will going is not already used, if there is not already a piece there, and if already there is a piece we cannot rotate, obviously. So there are these things to check, and at the end we need to check, obviously, if we are not in one of the border of the grid. So if we are not close to the right or the left border of the grid, because if we do a rotation we can go out of memory, because there is not space, there is not other cells after this one. So we cannot rotate this case. And those are all the things that I had to check for make it working properly. So I don't want to go deeper on the code, because there are a lot of lines, over 200, and every piece is different. So I leave you enjoy, watch the code and try to understand something about what I've written. Nothing, we can go to check. Okay, so for the last time we need to check if our code works. So 3, 2, 1, let's go. Let's see if we can rotate, and we can rotate, so it works. Well, technically we have done a copy of Tetris, so right now it works. And you can also play on it if you want. Now, I think that this video is gonna be very long, and I think that I showed you everything that I done. There are small features like the things that if I keep pressed S on the keyboard, the piece slow down faster. But I think that this is not very complicated to do, and you can figure out alone how to do it. Well, so that I think that we have finished for today. I told you everything that I found and I told for make this game. So I leave you in the description the repository with all my code. With all the code that I made for this game, so you can check and see. Also, I leave you in the description my GitHub if you want to check other projects that I done. There are a few maybe interesting. If you want, you can check it. There are some that maybe can interest you. And nothing. I thank you for watching, and see you in the next video and also next project. So, bye bye!